Hey everybody, welcome to our lesson video for 8.5. Today we're going to focus on the last of our three forms of a quadratic function. In terms of graphing at least, we're going to look at graphing a quadratic function in factored form, which you'll also sometimes hear called intercept form. So I want you to be comfortable with both names, and you might want to write both names on the top of your note sheet to remember that there's two different names for this form, factored or intercept. So take a moment, get a piece of graph paper out, and label that graph paper with the section number, the date, and the I can statement. And then resume the video as soon as you're ready. All right, so there's three types of quadratic functions, and I want to review them quickly before we get started. So take a moment, see if you can write down standard form and vertex form, because you should already know those two. And then resume the video once you've written those two down. All right, so standard form is y or f of x equals ax squared plus bx plus c. Vertex form is y or f of x equals a times x minus h squared plus k. And then finally, our last form today, our last form is called factored form. And factored form is particularly interesting. So f of x equals, and what makes factored form interesting is that it doesn't have a square directly in it, yet it is quadratic. So a times x minus p times x minus q. And you'll notice that there's no square there, which you would think there should be. But the reason for that is that when we multiply those x terms together, which we'll learn how to do next chapter, we will end up ultimately with an x squared term. So there is a square in there, it's just hidden right now, so it does still form a parabola. So let's take a look at an example of one of these. I've got a function here, y equals 2 times x minus 1 times x plus 2. And I would like you to use the table feature on your calculator. So put that function into y1, press second graph to get to the table, fill out a table from -3 to 3 in your notes, and then plot those points on a graph as well. So pause the video to do that on your own, and then resume the video as soon as you're ready. All right, so I'm assuming at this point that you've already completed this, so I'm going to put this up here as well. So I have -3, 8, -2 and 0, -1 and -4, 0 and -4, 1 and 0, 2 and 8, and 3 and 20. So if I go to plot these points, so -3, 8, -2, 0, -1, -4, 0, -4, 1, 0, 2, 8. What you'll notice here is something really interesting, which is that at the bottom of this parabola, those 2 points line up exactly, which means neither one of them can actually be the vertex. In fact, what's going on here is that the vertex has to be halfway in between those 2 points, because those 2 points are symmetrical to each other. And so, which makes it a little bit interesting because it means we don't know yet exactly what the vertex is. Now, of course, we'll be able to figure that out. But I do want to point out here, we do know something very cool. And what we know here is that if you look at the original function and you look at the points you've plotted, and specifically take a look at these 2 points right here. Because if you look at those 2 points, you'll notice that the 2 points on the x-axis, one of them is at -2, 0, and one of them is at 1, 0. And if you look at the original function, you might say to yourself, boy, that looks like it might match up, right? We've got x minus 1 here and x plus 2 here. And in fact, it does match up. Those 2 sets of parentheses are called the factors of a quadratic function. And the factors of a quadratic function will tell you what the x-intercepts of the quadratic function are. Now, that's not enough to actually graph the entire function. To graph the entire function, we still have to find the axis of symmetry and the vertex, which we'll talk about in a moment. Let's talk about vocabulary a little bit here. Because x-intercepts are incredibly important, and we're going to spend most of the rest of this year finding x-intercepts of quadratic functions, because a lot of things in engineering and physics are quadratic. And oftentimes you want to know where something starts and where it ends. For example, you might want to know where Aaron Rodgers' pass is going to land. If you're in the military, you might want to know where that missile you're launching is going to land. You can look at a bridge and see a quadratic function within the bridge, where the x-intercepts would be the places where the bridge meets the road that it's holding up. So x-intercepts are so important that they have a few different names. You're going to hear me interchangeably refer to x-intercepts this year as obviously x-intercepts, but we're also going to call them roots, and sometimes we're going to call them zeros as well. And we'll talk about the reason behind a lot of this vocabulary, and you'll see it come up and it'll make sense to you. But for example, I might ask you to find the zeros of f of x equals x minus 3 times x plus 4. And to do that, we're going to rely on something called the zero product property. And the zero product property is an important mathematical property that you're all very familiar with. All the zero product property says is that if I have two numbers, x and y, and I multiply them together to get 0, that tells you something about x and y. And specifically, it tells you that either x equals 0 or y equals 0, or possibly both. But you know for sure that one or the other equals 0 if the result when you multiply them together equals 0. And we can use that to find the zeros of a function like f of x equals x minus 3 times x plus 4. And the reason for that is that the zeros occur when the function equals 0. In other words, those x-intercepts happen when y equals 0. But if I'm multiplying two things together, x minus 3 and x plus 4, and I know that the result equals 0, that tells me that one or the other have to be equal to 0. And I can use that to now set each factor equal to 0 separately, and then solve them to get my answers. So in this case, I have x minus 3 equals 0, and x plus 4 equals 0. So I know that x equals 3, and x equals negative 4. Those are the two x-intercepts of that quadratic function, or you could think of them as the two zeros, the two places where I can plug in an x value and get 0 for y. So let's dive into this in a little bit more detail. So when we graph this, we've got our function a times x minus p times x minus q. That's a quadratic function in factored or intercept form. And we know that our x-intercepts are going to occur at two places, p comma 0 and q comma 0. We also know something else. We know that the axis of symmetry is going to give us the x-coordinate of the vertex. If we're looking for the vertex, the first thing we want to do is find the axis of symmetry. Because if we can find the axis of symmetry, that tells us the x-coordinate of the vertex. And the nice thing is, we can find the axis of symmetry, because if you look at this sketch over here, this example, the axis of symmetry is halfway in between the two x-intercepts. And another way to find something that's halfway in between two things is to take the average of those things. In other words, we know that the axis of symmetry occurs at x equals p plus q divided by 2, because that's the average of our two x-intercepts. So if we find the axis of symmetry, then we can find the y-coordinate of the vertex. All we have to do is plug in the x-coordinate to the original equation, and that will give us the y-coordinate. We'll go through an example of this so you can see exactly what I'm talking about here. So let's look at a final example here. So we've got, if I ask you to graph f of x equals negative x plus 1 times x minus 5. Now before you even start graphing this, one good thing to think about is this parabola going to open upwards or downwards? Because that's a good way to help you check your answer. So if I look at this, I see that there's a negative sign right here, a reflection over the x-axis. So I know in my head, this parabola better end up facing downwards. And that's a good thing to check because it helps you to make sure that you did the problem correctly. So if we wanted to do this problem, the first step would be to plot the zeros. And in this case, our zeros are the p and q from the original factors. In other words, our zeros are negative 1 comma 0 and 5 comma 0. And it's important to remember that they're always going to be opposite of what you see in the factors because of our form x minus p and x minus q. So in this case, p is 1, q is 5. Sorry, I apologize. P is negative 1. I spoke too quickly there. So if I put in my factors here, I'm going to plot negative 1 comma 0 and 5 comma 0. And then my second step would be to draw my axis of symmetry. And the axis of symmetry occurs at the average of the 2 points. In other words, at negative 1 plus 5 divided by 2. So that's 4 over 2, which equals 2. So I'm going to draw in my axis of symmetry, and I guess I should write this as x equals. So I'll draw in my axis of symmetry here at x equals 2, which is halfway in between the 2 points. And then finally, step 3, we want to find the vertex, and specifically the y-coordinate of the vertex. So to do that, I'm going to take my axis of symmetry and plug it back into the original function. So f of 2 equals negative 2 plus 1 multiplied by 2 minus 5. So that tells us that we have negative, and then 3 times negative 3. Or in other words, the result here is positive 9. So our vertex is going to occur at 2 comma 9. So I would come into my graph, put a point at positive 9, and then I'm going to draw in my function through those points. And I can see that it opens downward as I expected, which is a good sign. It tells me I probably did this problem right. And we can see our x-intercepts there as well as our vertex. So you'll notice that each form has some pros and cons. For example, vertex form tells you the vertex, but not the x-intercepts. Factored form, or intercept form, tells you the x-intercepts, but not the vertex. And standard form gave you not as much information for graphing, but standard form is one that is easiest to typically come up with the equation from a situation. So we've learned 3 different forms for quadratic functions, and at this point we've learned how to graph all 3. For your homework tonight, make sure that you use graph paper, and let me know if you have any questions.